Right, the amount of energy released or absorbed in a nuclear reaction. In a nuclear reaction is called Q value of reaction. Q value of reaction. The amount of energy released or absorbed in a nuclear reaction is called Q value, silent, Q value of reaction. Now suppose one reaction is like this, X plus A gives rise to you Y plus B plus certain amount of Q, energy releasing Q. Now this Q I can write as, this Q value I can write as, that is energy release. Mass of reactants minus mass of products, mass of reactants minus mass of products into C square. What is the mass of reactant? Mass into X, mass of X plus mass of A, now minus mass of Y, then minus mass of B into C square. So this is the Q value of the reaction. And if you know what is the Q value of the reaction, then you can understand also this reaction is endothermic or exothermic. Endothermic or exothermic. Okay. So how to find? Now you can understand, if Q value is greater than 0, then energy is released. Okay. If Q value is less than 0, then energy is absorbed. Energy is released now, that is called exothermic reaction. Energy is absorbed now, that is called endothermic reaction. So write this one. What is Q value of the reaction? Now the amount of energy released or absorbed in a nuclear reaction is called Q value. The left side is basically reactant. Okay. This is reactant. This is reactant, left side. Reactants. And this is your products. So if Q value is 0, then neither energy released nor energy absorbed. That's it. So normal reaction, no energy is releasing. Energy releasing is how to know? You may have in that reaction, you have heat energy. Heat energy is coming, heat. Otherwise light energy. Okay, like that. So thermal energy is coming. Or light energy, yes. Not like that. Neutral atom combine, reactions are there now. Neutral they are combined. Even if suppose uranium neutron, they both are neutral. If uranium hits one neutron, then so much energy will release. So not about any charge thing here. Okay. So no need to worry about it. But remember, in this reaction, charge remains conserved. Angular momentum remains conserved. Remember this in this reaction. But mass does not remain conserved. Why? Because now there is always mass, some defect will be there, right? Because of that, energy will produce. So in nuclear reaction, there will be no mass is conserved. Mass is not conserved here. Okay. But what happens? Other things are conserved. Mass number will be conserved. Mass number. And charge will be conserved. Angular momentum will be conserved. So remember that. Now Q value you wrote here. Now all of you listen. This Q value I'll write here. On star mark point I'll write if Q value greater than 0. That means Q value is positive. If Q value positive, then nuclear reaction is tell. how the nuclear reaction is? Reaction is exothermic. What do you mean by exothermic? Heat energy released. Or direct heat, right? Heat released. Similarly, if I'll tell Q value less than 0, then Q is negative. Now here what happens? The nuclear reaction is endothermic. So here heat is absorbed. Heat energy is absorbed. Here it is released. So note it down correctly. Q value positive, Q value negative. So no doubt here, you see Q value will find with this formula. After that we will see Q value is positive or negative. Okay. If Q value positive, it is exothermic. Q value negative, it is endothermic. They will ask you identify the reaction. So with this formula, mass of a reactant and a product will be given in question. Okay, directly last previous year questions many CBSE board they asked. Okay, so you remember formula, mass of reactants minus mass of products. Don't forget this. Okay, then after Q value, please. I hope you understood. Okay, thank you.